All right, next we're going to look at perpendicular lines in the coordinate plane. So we're going to be writing the equations in slope-intercept form of these perpendicular lines. And so it's important to know about the slopes of perpendicular lines. So when we're talking about perpendicular lines, those are two lines that meet at a right angle. So in order to make that right angle, the slopes of these perpendicular lines are opposite reciprocals. So each of these have to do with a different part of the slope. So when we say opposite, that's talking about the sign of the slopes. So one will be positive and one will be negative. So you can kind of see that in that diagram that I drew. So one line is positive and the other is negative. Reciprocal is talking about the fraction as you write it. So as a rise over run, you're going to have to flip that fraction. So we flip the fraction over to make it a reciprocal. So we change the sign and we flip the fraction to make opposite reciprocal slopes. So we are going to use our slope formula that we've been using in the last couple lessons, and we're going to use our slope-intercept form, y equals mx plus b. And we also have our symbols written here. So the symbol for perpendicular is this upside down T, and the symbol for parallel are two vertical lines side by side, kind of like those L's in parallel. And we're going to be able to tell if something is perpendicular by looking to see if the slopes are opposite reciprocals or if they're parallel, which means that they would have the same slope. So on example 1, we have one that I'm going to do and then one for you to do. So this question asks, is line P, I'm going to put some symbols over them, perpendicular to line Q? So line P goes through the points -1, 2, and 5, -1. Line Q goes through the points 4, 2, and 1, -4. So we need to find the slope of each one. So the first line we're going to find the slope of is line P. So I'm going to find the slope of this by plugging it into our slope formula. So y2, which is the second y, minus the first y. So -1 minus 2. And on the bottom, it's going to be x2 minus x1. So that will be 5 minus -1. So I'm going to subtract across the top. -1 minus 2 gives me -3. And then on the bottom, 5 minus -1 is +6. So I always want to try to simplify to see if I can. So here I have -3 over 6. First, to look at the sign, that's a negative over a positive, and negative divided by a positive is a negative. And then the fraction 3 over 6 can reduce. Both of those are divisible by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So that reduces to -1/2. So the slope of line P is -1/2. Next, we're going to find the slope of line Q. So the second set of points, 4, 2, and 1, -4, are the x and y values of line Q. And we're going to find the slope of it by doing that same formula. So y2 minus y1, -4 minus 2. And then on the bottom, x2 minus x1. So 1 minus 4. So as I subtract across the top, I have -4 minus 2, which is -6. And on the bottom, I have 1 minus 4, which is -3. So I'm going to reduce this first with the signs. A negative divided by a negative is a positive. And then 6 divided by 3 would be 2 over 1, or +2. So what we're looking for is if they are perpendicular, they will have opposite reciprocal slopes. So opposite means that one is positive and one is negative. So the slope of line P is negative. The slope of line Q is positive. So we have opposite signs. Now we need to know if they are reciprocals of each other. So is one fraction the same as the other if you flip it over? So in line P, we have 1 over 2. And in line Q, we have 2 over 1. So since those are the same numbers, it's just that in the first one, 1 was the numerator And in the second one, 1 was the denominator, and I'm looking at this fraction before I simplified it all the way down. That is the same, it's just flipped over, so they are also reciprocals. So is P perpendicular to Q? Yes, P is perpendicular to Q for this one. So you're going to check the slopes. They have to be both opposites and reciprocals to be perpendicular. So you have a your turn problem there that you will complete in the Google form. So now we're going to look at sets of lines, and we're going to decide if these lines are parallel, and parallel lines have the same slope. If they are perpendicular, which means that they are opposite reciprocals, or if they are oblique, which just means that they intersect. So this is anything else. So oblique is just a term that means two intersecting lines. All right, so if we have equations in slope-intercept form, then the slope is the number that's in front of the x. So we can tell if something's in slope-intercept form by checking to see if the y is by itself. So in both of these lines, we have a y that's by itself, so we're just going to look in front of the x to find the slope. So the slope of the first line is negative 2/3, and the slope of the second line is negative 3/2. So they're definitely not parallel because they are not exactly the same slope. So one is negative 2/3, the other is negative 3/2. So these are not parallel lines. So parallel is a no. Next, we're going to check for perpendicular. So perpendicular has to be opposite and reciprocals. So if I check the opposite part, that's my signs. One would be negative and one would be positive. And if I look, both of these slopes have a negative. So these are both negative. That means that they are not opposite, so this is not perpendicular. So if it's not parallel and it's not perpendicular, then these two lines are oblique. So anything that's not parallel and not perpendicular, if they're in the coordinate plane, those will be oblique lines. All right, our next set of lines, if I look and I check and see if it's y equals, the y is not by itself. So before I can check, I need to get these into slope-intercept form so I can see what the slopes are. So the first thing I need to do is I need to move everything away from the y in this first equation. So negative 2x plus 7y equals negative 4. I need to move this 2x, so I'm going to add 2x to both sides. Remember that variables and constants are not like terms. So instead, I think about it as a negative 4 and a positive 2x. And I'm going to rearrange those so that the x comes first. So the positive 2x comes first, and then the negative 4 comes second. So I bring down this 7y, and this is 7y equals 2x minus 4. So when I divide by 7, everything gets divided by 7. So I have 2/7 x, and I have negative 4/7, so minus 4/7. Neither of those fractions would reduce, so this is the equation of the line. So based on slope-intercept form, I have the y by itself, so the slope is in front of the x. So the slope of this first line is 2/7. In this second equation, there's only one thing that's over here with the y. It's being multiplied by 2. So that means that everything needs to be divided by 2 to get it into slope-intercept form. So that's going to leave me with y equals, and then I'm going to divide. So negative 7/2 doesn't reduce, but I do write it as a fraction. And then 10/2, 10 divided by 2 is 5, so I'm going to put a plus 5. So now that this y is by itself, my slope in this line is negative 7/2. So if I look to be parallel, they have to be exactly the same, and these are not the same. To be perpendicular, they have to be opposite signs, and they have to be reciprocals. So for opposite signs, the first one had a positive slope and the second had a negative, so they are opposites. Now to be reciprocals, they have to flip the fraction over. So on the first one, the 2 is in the top, and on the second one, the 2 is in the bottom. So that one flipped over. In the first, the 7 is on the bottom, and in the second, a 7 is on the top. So they are also reciprocals. So these two lines are perpendicular. So the slopes were opposite reciprocals, and that makes them perpendicular lines. So now we're going to start writing equations of perpendicular lines, and we're going to need to use that knowledge of opposite reciprocals in order to figure out what the slope will be. So example 3a here is a check your progress problem. So we're going to skip it, and we're going to look at 3b. So notice that this equation that was given to me is not solved for y. So I don't know what the slope of the original equation is yet. So to figure that out, I'm going to write this equation, and I'm going to solve it so that the y is by itself. So the first thing I'm going to do is move this term that has the x to the other side. It's positive over here. So I'm going to subtract 2x to cancel it out, and then I'll subtract 2x on the other side. So since 3 and negative 2x are not like terms, I'm just going to put that plus in front of the 3 so that I know that it's positive. And then I just rearrange it so that the x term comes first and the constant goes last. All right, so I bring down the 7y, and then I'm going to divide everything by 7. So now I have y equals, and so both of those numbers get divided. That's negative 2/7 x plus 3/7. So in this line, since this is the original line, the only thing I care about in this line, once I have it in slope-intercept form, is the slope. I do not care about this y-intercept. I need to find a new y-intercept. So all I care about is this slope of that original line. I want to be perpendicular to this given line. So that means that I need to be the opposite sign. So since this is negative, my opposite reciprocal slope is going to be positive. And then I also want to flip it over. So I'm going to have positive, and then I'm going to flip it to be 7/2. So this is the slope that I'm going to use when I try to solve this equation. So now that I have this slope, so I'm using 7/2 as the slope of my perpendicular line. I'm going to plug that in, as well as the x and y value from this ordered pair. So x is 4 and y is -1. So for y, I plug in -1, and I have -1 equals 7/2. I'm going to multiply that by the x value, which was 4. And then I want to find this b value for my new line. So the first thing is to multiply. 7/2 times 4 is going to be 14. So 14 plus b equals -1. And then to find that y-intercept, I subtract 14 from each side. And -1 minus 14 is -15. So finally, I'm going to put this all together to make an equation. And that's going to be y equals my perpendicular slope, which was 7/2. And then the y-intercept I just found was -15. So that's going to be -15 at the end of this line. So the perpendicular line to the one that was given that goes through that particular point for -1 is y equals 7/2x minus 15. So there is a check your progress problem on the Google form that has that same process. You have to get the slope of the original equation by putting it into slope-intercept form, and then use the perpendicular slope to find your new line. The last one we're going to look at is one of our special lines, one of our zero or undefined lines. So here, the whole equation is y equals 7. So I can rewrite this as y equals 0x plus 7. That 0 is what makes the x value disappear. So the x doesn't show up in the equation because it had a 0 slope. So remember that a 0 slope is our our horizontal line. So 0 slope is a horizontal line that would cross at 7 on the y-axis. And so to be opposite of a 0 slope, if that's the horizontal line, To be perpendicular, you're going to have to be a vertical line. So we are going to have an undefined slope for our perpendicular line. So let's look at what we have here as our equation of our original line. So notice that this equation is a y equals line. So if I'm only dealing with the y value and I want to be perpendicular to that, I'm going to use the complete other value. So a zero slope line is a y equals line, and an undefined line is a x equals line. So to be perpendicular to this y equals 7, I'm going to need an x equals line. But in order to get that x equals line, I need to look at this ordered pair that was given to me. So in the ordered pair, the x value I was given was -1, and the y value was +1. So if I am writing an x equals line, and I want my x equals line to go through this particular point, I'm going to look at the x value that was given to me. So in that point that I was given, the x value is -1. So the perpendicular line that goes through that point is going to have an equation of x equals 1. So this is the equation of a vertical line that hits the x-axis at -1.